given the differential equation, f prime of x equals f of x times 1 minus f of x, and f of 0 is equal to 1 over 18. So I want to solve for f of x. In order to make this problem easier, I'm going to let f of x equal y. Okay. So this turns into y prime equals y times 1 minus y. And really, y prime is just dy over dx. And so this is a separable differential equation. I'm going to bring the y times 1 minus y in the bottom. And on the right, I'm going to multiply the dx. So at this point, I can take the integral of both sides. And the nice thing is about dy over y times 1 minus y, I can break this up into two fractions. So this is just 1 over y minus 1 over y minus 1. And then the integral of dx is just x plus a constant. So you can use partial fraction decomposition for this, but this looks easy enough where hopefully you can do a little guess and check and come up with the answer. Okay, in the next step we're going to integrate 1 over y is ln of y, and then 1 over y minus 1 is just the ln of y minus 1. So that's going to equal x plus c. Now ln of y minus ln of y minus 1 is just ln of y divided by y minus 1. I want to solve for y, so that means I have to undo the natural log. So I'm going to raise both sides e power. So the y over y minus 1 comes out. And really, because I have an exponential, the exponential is always positive. So this is always positive. So that means I can get rid of the absolute values. So I can just write it as y over y minus 1. And here, I can break up the e to the x plus c as e to the x times e to the c. And so this e to the c is just a constant. So I'm going to call that a. So this is just a times e to the x. Okay, so where a is a constant. And I'm going to choose to do this because it just makes things a lot nicer. Okay. The next step, I'm going to multiply both sides by y minus 1. So I'm going to distribute the y minus 1 with the a times e to the x. So we get a times e to the x times y minus a times e to the x. I want to solve for y, so I'm going to move the a times e to the xy to the left. And then I'm going to factor out a y. And then in order to solve for y, I have to divide both sides by 1 minus a times e to the x. Now I have solved for y, but I need to use the initial condition that, well, the initial condition was f of 0 being 1 over 18. But we said let f be y. So when x is 0, y is 1 over 18. So plug that in. 1 over 18 for y, x for 0. So if x is 0, e to the 0 is 1. So I'm not going to bother writing that. So this comes down to me finding what a is. So I'm going to cross multiply. I'm going to have 1 times 1 minus a is equal to 18 times negative a. So I'm going to add the 18a, subtract the 1, and I get a is negative 1 over 17. So this a is going to be needed to plug in over here for both a's. Okay. So I'm going to replace a with negative 1 over 17. And keep in mind, there's a negative in front of the a's. So the two negatives will make it into a positive. And now I can multiply top and the bottom by 17 to simplify. So the 17 is going to cancel at the top. I'm going to have e to the x, and then the 17 has to distribute both the 1 and the 1 over 17. And we said let y be f of x, so we'll just write it in terms of f of x. So by the way, that step was optional. I think it's easier to visualize that way. And so this is our final answer.